everybody. We're going to continue on with 6.2a. We're going to continue with our identities. I'm just going to show you some different things to look for, different ways to approach these problems. One is looking for a greatest common factor. I'm looking between the two terms, have to be turned into one term. So let's just start with factoring out 1 tan theta. They each share at least 1 tan theta. So we take, or tan x in this case, take out tan x. That's going to leave me with secant squared x minus tan squared x. This is coming from those Pythagorean identities where it's tan squared theta plus 1 equals secant squared theta. And what we're doing is just subtracting the tan theta to the other side. So this is essentially the same thing as 1. You will show the replacement of the 1 in there, because again, this is about the quality of the work that we need to see, getting us to tan x. So what originally looked like a kind of complicated problem actually wound up not be so terrible. Looking at this first one here, I do notice I have a difference of perfect squares here, so this first part on the left here is factorable. So we're going to get secant squared x minus tan squared x times secant squared x plus tan squared x. And as we used this identity before, it is just subtracting that tan squared x to the other side of the secant. This is the same thing as 1. We will show the replacement. Since addition is commutative, we are allowed to switch the order here. And then when you multiply by 1, we wind up with tan squared x plus secant squared x. All right, let's go to the bottom of the page here, the second half. Again, we always need to look to see if we can factor our identities here. The numerator here is factorable, so we're going to have 1 minus 3 sine x times 1 plus sine x. All this, it's going to be over cosine squared x. I'm going to replace this at the same time to 1 minus sine squared x here. When I do that, this denominator now becomes factorable as well. So I'm going to just, sine x, 1 plus sine x, and I'm going to get 1 plus sine x over 1 minus sine x. These guys cancel out. And then I am left with, in both the numerator and denominator, what we need. We rewrite it. And we have established our identity. A good approach, and one that I use quite often, is probably my go-to, is changing everything over to sines and cosines. So let's look at this first one. Here, the first part is already sine and cosines. Tangent is sine x over cosine x, and cotangent is cosine x over sine x. In order to add or subtract fractions, we would need common denominators. So I'm going to leave this first part here. I'm just going to bring it down, noticing I don't leave anything dangling up on the top. And what I want to establish is a common denominator of cosine x, sine x. So I'm going to multiply this first part here by sine over sine. That's going to get me sine squared x. On this one, we're going to multiply by cosine x over cosine x, and that's going to get me cosine squared x. That should look fairly familiar to you guys. That is your basic Pythagorean identity. So I'm going to go ahead and change that to a 1. Again, bringing everything along because the value is in the work of what we're seeing. Sine x. when you multiply your fractions, you just multiply your numerators and your denominators. So I'm going to go ahead and do that at this point. So now I've got sine x plus cosine x all over cosine x sine x. Since we are over one single term in the denominator, we can split the two because I need to go from this one term into these two terms here. So that's going to get me sine x over cosine x sine x plus cosine x over cosine x sine x. The sines will cancel here, leaving us with, I'm going to have to go this way a little bit, 1 over cosine x. The cosines will cancel here, leaving us with 1 over sine x. 1 over cosine is secant x, 1 over sine is cosecant x, and we have proven our identity there. All right, turning your page over, another common method, and we did a little bit of this in the other lesson, was using a conjugate. So if you don't know what to do, and you see in this situation the denominator here, let's go ahead and multiply everything through by the conjugate. So in the numerator, we get sine x times 1 plus cosine x. And in the denominator, since they're conjugates, we're going to wind up with 1 minus cosine squared. Oops, it's a theta, not theta. We're using x here. But cosine, 1 minus cosine squared x is that basic Pythagorean where we scoot the cosine to the other side. So that's going to be the same as sine squared x. One sine will cancel from the numerator to the denominator. Since we are over just one term in the denominator, we can go ahead and split the two. And then when we, our reciprocal identities here, 1 over sine x is the same thing as cosecant x. Cosine over sine is the same as cotangent x. Again, establishing that identity. Anytime you're looking to add, you may need those common denominators. So I want a common denominator for number 6 here of sine x. The first term has it. I don't need to do anything to that one. But to get a sine x here, I'm going to have to multiply both the top and the bottom part of the fraction. So we're going to get sine squared x. That is your very basic Pythagorean identity. So we get 1 over sine x, which does become cosecant x. So that one was pretty simple and short. We have 2 more just to review for today. Let's see, we've got to get this moved down a little bit. We talk about lowest common denominators and conjugates at the same time. So this first one, I'm going to multiply by 1 minus secant minus 1. So on this side, I'm multiplying both top and bottom by secant x minus 1. On this side, the conjugate would be secant x plus 1. And I am multiplying both the top and the bottom. That's going to establish just some common denominators here. So on the top, we're going to get secant x minus 1 plus secant x plus 1. And then the common denominator would be secant x plus 1, secant x minus 1. If I multiply these guys together, they are conjugates. I'm also going to combine up like terms in the numerator. So negative 1, positive 1 cancels. I wind up with 2 secant x, which is great because I'm looking for a 2 over in my identity. Multiplying the conjugates, we get secant squared x minus 1. That is the same as tan squared theta. Tan squared x, yeah. We just subtracted that 1 over to the other side. So 2 secant x over tan squared x. At this point, I'm a little stuck, so I'm going to start changing everything over to sines and cosines. So it's going to be 2 over cosine x all over sine squared x over cosine squared x. One of those cosines will cancel out, so we're going to have 2 over sine squared x over just 1 cosine x. Oh, not squared, just cosine x. Now remember, with the fractions here, we can keep, change, flip with the dividing of the fractions. So it's going to be 2 over 1 times cosine x over sine squared x. I'm going to split out the signs here, so I'm going to have 2 times 1 over sine x times cosine x over sine x. And that's going to leave us with 2 cosecant x and then cotangent x. I did not write it in the same order it was shown, so I'm going to go ahead and change the order there to be 2 cotangent x, cosecant x. That was a long one. Okay, number 8 is not going to be quite that lengthy. So I'm looking here, and I want to see what I can do here. I need to keep my cosine squared x in there. So what I'm going to do is, and I need 2 of them, I'm going to take out this sine squared x and replace it. The minus is there. Anytime I replace anything with a minus, I throw up a bracket to remind myself that I will need to distribute. Sine squared x is the same as 1 minus cosine x. Distributing that negative through now. So I get 2 cosine x minus 1, which is exactly where we want to be. My advice to you guys on these identities is that big rule. Do not just sit there and stare at these. Try something. The only way to get better is to just try. You're going to make a couple of mistakes. You're going to back yourselves back out. Keep going.